We are going to go ahead and continue on with endocrinology and physiology, and we're starting with estrogens and testosterones. So we're now moving on to estrogens and progesterones just for a little bit. We're still in the anterior pituitary, which we quite haven't finished yet, but we're going to take a break and talk about estrogens and progesterones. We just got done talking about FSH and LH, and remember, those are anterior hormones from anterior pituitary hormones. But we're going to take a break and just talk about kind of how those are involved with a woman's menstrual cycle. And there's several pages about this. So what I want to do is take it to the whiteboard and kind of work this out up there. So let's go ahead and work that out together. So the first day is day 1 of menstruation. The last day we'll say is day 28 because on average it's a 28-day cycle. So that would be the day before a female starts menstruating again. Now, if we cut this into half, about day 14, on day 14 there's something called an LH surge. And guess what? That's caused by luteinizing hormone, or LH. All right? LH surge releases an egg. And we want to know exactly what that egg follicle is called, and it's released from a Graafian follicle. Okay? The Graafian follicle then releases an egg into the fallopian tubes and through the uterus. At this time, it can be fertilized and become a baby, or if no fertilization takes place, it ends up not connecting to the uterus, but instead hormones decrease and the cycle starts over again. The first half of this phase before day 14 is called the follicular phase. That starts on day 1 of the cycle. The second stage is called the luteal phase, and that starts at the beginning of ovulation and goes until the next bleeding cycle. During the follicular phase, FSH is high, and that's what stimulates the follicular development, maturation of the ovum, and then secretion of estrogen. At day 14, after the LH surge, progesterone increases. When progesterone increases, that inhibits further uterine endometrial growth. That way, if pregnancy occurs, it can be properly planted into the endometrium. So that requires another hormone, which is called chorionic gonadotropin. That's secreted by an embryo. If we have the presence of chorionic gonadotropin, then pregnancy has occurred and menstruation will not take place again. If there is no embryo, then progesterone levels decrease, as does estrogen, and the cycle starts over. So that's a little bit just about how FSH and LH and all of that interact in a woman's menstrual cycle. So the next thing and last thing we're going to kind of talk about with the anterior hormones is prolactin. We talked about this in Path 2, but remember, prolactin allows for milk production, okay? And again, anterior pituitary hormone. So now we're going to the posterior pituitary hormones, and there's 2 really that we need to talk about. The first one is going to be ADH. Now, ADH we talked about when we talked about the nephron, but again, antidiuretic hormone is a posterior hormone, or posterior pituitary hormone, excuse me. But what's so interesting is it's actually created in the hypothalamus and then stored in herring bodies in the posterior pituitary. Okay, and again, ADH is responsible for making sure we don't get dehydrated by taking fluid out of the nephron and putting it back into the bloodstream. Okay, so the other one then is oxytocin. Now, oxytocin also we talked about in PATH in terms of somebody who, when we talked about just breastfeeding, because oxytocin, again, posterior pituitary hormone, allows for milk ejection. Okay, so that's all you need to know about there. All right, so we're going to talk a little bit now about just endocrinology of calcium and phosphate. So when we think about calcium turnover, extracellular calcium we know is found in bones. And it's kind of one of those things where the blood serum calcium has a direct relationship for how the calcium in our bones are doing. So if the blood in our calcium, or excuse me, if the calcium in our blood decreases, guess what's going to happen to the bone? It's going to give bone calcium to the bloodstream to be used by the rest of our body. Same thing, if we have an excess of calcium in our bloodstream, it's going to be given back to the bones. And that's important when we're thinking about parathyroid hormone as well as osteoclast and osteoblast activity. All right, So when we think about this, bone formation reabsorption, I would just make sure you know what does what. So for example, bone formation is stimulated by growth hormone. It also is stimulated by estrogen. In fact, after a female is menopausal, her bone strength, her bone density goes down quite a bit in that first year. All right. Also, insulin, androgens, vitamin D, they all help with bone formation. Now, it is inhibited by PTH, parathyroid hormone, and then cortisol, which makes sense because we keep talking to you about how steroids are hard on our bones and can cause osteoporosis if taken too much of them, correct? All right, so let's flip sides then. Bone reabsorption is stimulated by parathyroid hormone, vitamin D, and cortisol, and it's inhibited by our sex hormones like estrogens, androgens, and then calcitonin. So let's talk about the calcitonin and parathyroid hormone relationship. So when we talk about parathyroid hormone, the parathyroid gland secretes two types of cells, okay? The first one is chief cells and then oxyphil cells. Well, those chief cells are the ones that secrete parathyroid hormone. Now, what parathyroid hormone is responsible for is basically making sure that the levels in the bloodstream of calcium are high. So it basically takes it out of the bones and puts it into the bloodstream, okay? So PTH, again, stimulates osteoclast activity. You can go ahead and highlight there. So the opposite then of this would be what calcitonin does. Now, calcitonin is synthesized in the parafollicular gland of the thyroid gland, okay? In the parafollicular cells, I should say, of the thyroid gland. And its job is to put calcium into the bones, all right? So you can see how those two would work against each other. So it inhibits osteoclast activity. Okay, calcitonin inhibits osteoclast activity. So I would be aware of that just so you know the relationship there. Okay, so we are finished with the hormones coming from the anterior pituitary, the posterior pituitary, and now the parathyroid gland. So let's go ahead and take a break there. And when we come back, we're going to go ahead and talk about pancreatic hormones and diabetes.